Bismillahirrahmanirrahim. Now I would like to discuss to you solution of partial differential equation. How we can solve a partial differential equation if we have a partial differential equation. So first of all, I would like to start from the direct method. In the direct method, what we have to do in the direct method, we directly apply integration on both sides and integrate both sides partially. So here we have a differential equation in example number 1. Dabba 3 z upon dabba x square into dabba y is equal to cos 2x plus 3y. We have two independent variable which depends on two independent variable x and y, and the dependent variable is z here. So first of all, what we have to do, first in the first step we will integrate with respect to x, so that this above expression can be written as dabba times of dabba 2 z upon dabba x dabba y, because we have dabba 2. So from this dabba 2, shift one dabba upon dabba x at left hand side, right hand side, so the right hand side becomes cos 2x plus 3y into dabba x. Now after the integration, this partial sign and integral sign, these two sign will be cancelled out, because these two sign are the reciprocal of each other. That will be cancelled out. Only we will have dabba 2 z upon dabba x into dabba y is equal to right hand side integral of cos 2x plus 3y into dabba. We are integrating here partially with respect to x, so 3y will be constant, but this is in the angle. So when you are first integrating this term, this will be the cos, and you know that the derivative of cos is sine, integral of cos is sine. So we will write the integral of cos, that is sine 2x plus 3y. And we must have, before the integration, when you are going to integrate a trigonometric function, you must have the complete derivative of the angle. So what we have angle is 2x plus 3y, and the derivative of 2x plus 3y would be 2. So we don't have 2 here, so we directly integrate and divide by 2. That is from balancing the integral, and plus integration constant, because when we are integrating with respect to x, so we are taking integral constant function of y, that will be the integral constant in our very first after very first integration. Now again we perform the integration, so that this time at the left hand side, that will be what, after the second time, that would be dabba z upon dabba y is equal to 1 upon 2 times minus cos 2x upon 2 plus x f of y plus u of x. So how we got this one? When you will integrate at the left hand side, there this dabba x will be shifted at the right hand side. Only this dabba 2 will be divided into dabba. So one dabba will be cancelled out from the integral. Only remains dabba z upon dabba y, and sine will be integrated as integral of sine would be the minus cos, and divided by 2. Already we have 2 to the 4, that would be 1 upon 2 is already here. So 1 upon 2 minus, this is the integral of sine is minus cos 2x plus 3y divided by 2 plus, and you know that constant, integral of constant, there is constant term, this will be come out from before the integral. So the integral of 1, that would be x. So f of y, integral of 1, that would be x plus again integration constant g of y. Or you can also write it c1 or c2, so no matter. So third time, now we are going to integrate. So the equation becomes integral at the left hand side, integral of dabba z is equal to minus 1 upon 4 times integral of cos 2x plus 3y dabba y plus integral of x dot f of y dy plus integral of g of y dy. And here this partial or integral both will be cancelled out. Only we will have z is equal to minus 1 upon 4. What is sine? It is integral of cos. Integral of cos is sine 2x plus 2y, and we are integrating with respect to y, so we must have the derivative. We don't have the derivative, so we must be divided by 3 to this term to balance. So plus x times, we are integrating again with respect to y, so x will be the constant here, and integral of f, that will be the capital F. Integral of f would be the capital F, right? So this is the integral of small f of y, plus also g of y is constant. So the function of, we are going to integrate with respect to y, so the integral of small g would be the capital G plus h of x, that would be treated as a constant here. So now our constant of integral is h of x. Finally, we can write it as z is equal to minus sine 2x upon 2x plus 3 upon 3 plus x into f of y plus g of y plus h of x. So this is our required solution of partial differential equation by using the direct method. Now we have another example. In the second example, we have daba 2z upon daba x daba y is equal to x square y. Now this times we have two functions in product form, or here we have a condition, that is boundary condition, subject to the condition, that is z is equal to x, 0 is equal to x square, and z is equal to 1, y is equal to cos y. So first, how we would like to start this question? By integrating with respect to x. So left hand side becomes daba z upon daba x is equal to integral of x square y daba of x. So the when we will integrate with respect to x, that would be x cube upon 3, and y is a constant here. So y is a constant, and integral of x square will be x cube upon 3 plus a function of y, that is a constant of integration. Now daba z upon daba y is equal to 1 upon 3 x cube y plus f of f1 y. Now we will integrate with respect to y. So at the left hand side, this can be written as z is equal to 1 upon 3, and integral of this term with respect to y, we will write it as plus f of 1 y daba y. So here now we are going to integrate with respect to y partially. So x cube will be the constant here. So x cube upon 3 will be right before the sign of integration, and we will integrate only y. The integral of y, that would be y square upon 2 plus integral of small f, that would be the capital F of y plus g of x is the constant of integration. Now we can write it as z is equal to x cube y square upon 6 plus f of y plus g of x. This is our equation number 1. Now using the condition as we have z is equal to x square and x is equal to x and y is equal to 0. This is our first condition. When we are applying first condition, so equation number 1 becomes, for instance, z square, we will write x square is equal to x cube into y, value of y is 0 upon 6 plus f of 0 plus g of x. So that from this equation we will obtain the value of g of x, that would be x square minus f of 0, because this factor will be 0. Now z is equal to x cube y square upon 6 plus f of y plus x square minus f of 0. This is equation number 2. Apply the other condition. What is the other condition we have? Z is equal to cos x, x is equal to 1, and y is equal to y, right? So now when we are applying, substituting second conditions, that is z is equal to cos y is equal to 1 cube, that is x cube y square upon 6 plus f of y plus 1 minus f of 0. So cos y minus y cube upon 3 minus y cube upon 6 plus f of 0 minus 1 is equal to f of y. So how we get f of y? What is this is the f of y. Now from this equation, z becomes x cube y square upon 6 plus cos of y minus y square upon 6 plus f of 0 minus 1 plus x square minus f of 0. So f of 0 will be cancelled out. So the rest of term which is remaining in this equation, that is z is equal to 1 upon 6 x cube y square plus cos of y minus 1 upon 6 y minus 1 plus x square, which is the required solution of partial differential equation. So I would like to request you, please, if you like my effort, like and subscribe my channel. I would be really thankful to you. Assalamu alaikum.